Now let's check out the module we are interested in, which is the MDR TB module. So it's E Squared Systems OpenMRS module MDR TB. This is a fork. I'm going to share the forked repository version, but let's just open this clone and open this project in a new window and start exploring our main module. Now let's let it complete the import process. That's the good thing about PyCharm, it takes care of plenty of such processes. It's going to automatically import and build the OpenMRS module itself. Meanwhile, let's look at the module itself. Again, we have module, we have a POM file for Maven, we have an API module, we have an OMOD module, the same structure. However, you will find this file to be much more content heavy as compared to Common Lab module. The reason being, our MDR TB module has too many moving parts. Yes, too many moving parts. My memory. So it has dependencies all around around several other modules. First and foremost, when you check out this project, please switch to this branch called OMRS2-upgrade-TJK-2.8, because if you go through, you have OpenMRS upgrade Tajik, OpenMRS upgrade Tajik 2.4, and now this latest one 2.8. These are three separate branches. The master branch, that's no longer relevant. We are working on this OpenMRS upgrade Tajik 2.8. That's the branch we will be working on. That's the first thing to note. Now let's go through the properties. First of all, after you've declared the module's parent, its artifact, its version, name, description and all, we have three modules. One I have disabled, that is for testing, and I will explain why. This has to be dealt like exclusively. These are all properties which are telling exactly which versions are being used for certain dependencies. So the minimum version required of OpenMRS is 2.4, meaning this module is going to be compatible with OpenMRS 2.4 as well as 2.8. That's the aim. Then you have version names of all the dependencies, all the modules which this module depends on. You know that Common Lab module was depending only on REST module, web REST. Here we have a bunch of more dependencies. So there's address hierarchy module, the API of it, not the OMOD, just the API, calculation, HTML widgets, legacy UI module, logic module, reporting REST module, reporting compatibility module, and then XStream API. Finally, we have the REST module, OpenMRS REST module. This is the whole suite of modules you need. Then there are some more exclusive libraries, Java libraries, which we are using. So we are using Groovy version 2.4. We are using JSON, it's an upgrade version. Servlet, JavaX Servlet, then POI, XML Worker, JUnit, Mockito for mocking, and PowerMock. We were using YodaTime, we no longer need it because Java provides a very good class now from version 1.8 onwards. These are the same repositories we were talking about, all three, nothing new here. This is the plugin repository from where OpenMRS plugins are being read. Then the whole list of dependencies, we declared versions over here, and we are just calling their variables down here when we are declaring the dependencies. So you can see our module is depending on OpenMRS API, right? And API's jar file as well as test jar for test objects. Then the web, then test jar of the web, and then OpenMRS test. These are managed dependencies. And then for exclusive dependencies which are not being managed by OpenMRS per se, we have JUnit, PowerMock, all of those we have defined over here. Right? So this entire section is just dependencies. Then again we have plugins, and we are using an upgrade version of OpenMRS Maven compiler plugin, and this over here is making this module compatible with Java 11. So we are using release 11, and this argument line is making sure that this works in Java version 11 as well, because I have version 11 installed. You can backwards compatible it, you can make it backwards compatible, you can remove this if you are exclusively working on 1.8, but that's just one add-on. And the target version of OpenMRS is 2.8. This is a profile for version 2.8. If you need to support more versions, you can add more profiles. Now there's nothing else in this POM file, just the dependencies which were worth mentioning. I'm going to go back to the anatomy of our module. Actually, let me check real quick something. Yes, so we are going to be again working on, let's model DAO service controller, and then there are certain utils. That's what we will be working with. Let's now talk about the module's code. We have API and we have OMod. The difference is between MDR TB module and Common Lab module is that this is much there's much more going on in this module than just lab forms. So there are plenty of files to look into, plenty of resources to check, and a whole lot of files. It won't make sense to cover each and every file, because we'll just talk about the packages, and that should be sufficient to explain how the rest of the module is going to work. So I'm going to take an example of TB03 form, and this time I'm going in reverse order, meaning I'll start with REST, the REST module package, and then go all the way to API. Let's navigate to TB03 form. Right? We have TB03 form resource controller. Now this is the endpoint /MDR MDR TB /TB03, and if you are providing UUID of any form, you are going to get that form data. That's what the endpoint is doing. Now the rest, you can see there is an abundance of all the fields in this module. First of all, let's go on top over here. This form resource controller is expanding data delegating CRUD resource. So this is not metadata, this is data, and its class to convert to and from the data conversion is simple TB03 form, which is POJO, plain old Java class. This is the object which the resource controller, is going to accept as an input and return as an output. Now you will see there's no shortage of code, by the way, in this model. This is thousands and upon thousands of lines of code. But once you understand one form end to end, pretty much every other form works the same way. So you can see this is again get representation description. So we define the representation, and according to that representation we have these properties attached. So right now we have full representation only here. Not full representation, whichever the representation we are passing, and on top of that the recursive methods are also, the nested objects are also going to be represented the same way. What do I mean by that? For example, if you have called this with ref, let me go ahead and actually make a call to TB03 form. That will be much better than TB03 MDR TB03. The form we are going to call here is MDR TB TB03, and let's pick this form, see if it exists or not. Yeah. So there is an encounter with this UUID which is representing a TB03 form, field 1. I didn't pass anything here, right? If I say v is equals to ref only, what's gonna happen is, see this anatomical site, this was a concept. I'm saying reference, bring me references of TB03 form. Inside TB03 form there was a concept. For that concept, this representation was also reference. If I go ahead and say full, now the same concept, we will see a full representation of that concept. Where is that? It was anatomical site. Yeah, this was the concept, and now you are going to see full representation of that concept itself. Meaning it's not really worth it to fetch full object of any form unless you really want it. So we generally fetch a full complete form only when we are fetching one form, one record only. When you are fetching list, never use full, because it will be a very beefy kind of object that's going to be returned. So this is the default, and what it's returning is an encounter, then all these properties, right? Anatomical site, treatment site CP, patient category, registration group, all the variables we have, HIV status, etc. in the TB03 form, you have them here. Now you may have certain bug, say HIV status not being read, the form is not returning HIV status, or you are unable to see HIV status on the UI. The first thing you're going to check is, are you able to see HIV status here in the REST call? That's basically your litmus test to tell if the problem is with the front end or with the module. That's the first thing you'll always be checking. Where does the problem lie actually? Where do we want to make the change happen? Now, coming back here, you have this entire representation. It's returning the form, and this is the get model. I fetched a single object. I provided a default representation. These are the three things that are going to be returned. Full representation is going to give you all the variables, right? That's the get one. Then if you need create, so for create you need an encounter, a patient program ID, and inside encounter you have all of the observations provided already. We also have an get update model, which is exactly the same as create model. Whether you're creating a new TB03 form or updating an existing one, the fields will remain the same, right? Here we are providing creatable properties, patient program UUID and encounter. Remember, this entire REST layer does not recognize the integer IDs that are stored in tables. So the whole REST layer works over UUIDs and not the integer IDs, which are auto incremental IDs. That's one of the primary rules of REST module. So no integer IDs, only UUIDs. Then there's display string. You can forget this. Set ops, do search. Okay. If you're searching for a certain data object or one or more forms, this is the one that gets called, and it takes in queue parameter. Inside queue you search for patient ID. So right now you can search for TB03 forms only by one parameter, that is going to be your patient UUID. That's it. Nothing else is included in the search parameters. So if you do not on the UI, of course this matters a big deal, because you need a patient's identifier to fetch all the forms of that patient, or you need an encounter ID. These are the two ways to fetch a TB03 form. So if there were more than one forms, you can pass on the patient ID and you'll get all those results returned. All the TB03 forms associated with that patients are going to get returned. Now have a look what happens. How does data get returned? See, there is this a simple TB03 form class over here. This represents a TB03 form, but this is not the complete class. This is only the class that the transport layer, the REST API layer is using. If you want to see the complete class, that's called TB03 form, not simple TB03 form, but TB03 form. That's the main target. This is where everything is happening. And you get these, each one of these classes is thousands, hundreds upon hundreds of lines of code, and which makes it quite difficult to work, by the way, on this module too. There's some part we cannot touch, there's some part we cannot remove. To make any change we have to rigorously test for the ripple effects. These are a few issues with this MDR TB module. But anyway, as we want to return TB03 forms, what this function is doing here is it's fetching patient, fetching the encounters by patient, and filters out all the TB03 encounters. Each one of these encounters is converted into a simple TB03 form object, and that list is then returned, that collection is returned. So How that happens is that there is a constructor in symbol TB03 form class. It accepts the complete object and then sets its properties into this current object, and that object is then returned. Similarly, you can convert a simple TB03 form into a complete TB03 form. So when you are fetching data, this is what you use. When you are creating a new object, obviously the REST API is going to give you simple form. You are going to convert that simple form into TB03 form. That's how it works. So this is search. This one is when you are fetching by encounter ID, and you call save by supplying an object of simple TB03 form. Good. Now let me see if I can find an example of how the TB03 form post works. I have an example of TB03U form. So if you look into the packet that is being sent to store this form, you have patient program UUID, you have an encounter. Inside the encounter you have observations. For every observation you have concept and you have its value, and these are all you need to create a new TB03 form. Everything is encounters and observations, as I explained yesterday. Okay, moving on. This is your patient. This is your TB03 form, which is being served like this. But what exactly is happening behind the scenes again? Let's see. See, we don't have custom tables to represent each and every form in MDR TB module. All these forms, all this data is represented as a collection of encounters and observations. And encounters and observations are quite loose-ended, so you can actually store any number of observations, any type of data, anything. Which is why we have encounter types and encounters against those types and a collection of observations, and that's it. Now, how those observations are being treated, that's a whole different story. You have to literally pick every concept and understand how it's being used in the module if you want to make any change. So let's go ahead, and it's actually not as difficult as it may sound. You can, if you worked on one form, then you have covered pretty much 90% of the module. It's just understanding the flow of one form, that's the trouble. So let's go through this call, this save call. Let's say I made a post call from the front-end application, Django application, to store a new TB03 form. So what's happening is we have a service instance, MDR TB form service implementation. Right? What this service is going to do is it's going to process a TB03 form. By process, what exactly do I mean? When I have a new form, it's called delegate. First of all, I am going to fetch its encounter, right, and see if the provider exists or not. If the provider exists, good. If it doesn't exist, the current user becomes the provider, right? So you have context.getProvider service, and get by identifier, current username is going to be returned as a provider because it has to match, and that will become our provider, which actually means something here. If I go into providers, manage providers, let's say I'm searching for OS.Hussain. Now this is a very important thing to note. This string OS.Hussain must be exactly as my username OS.Hussain. The identifier must match with the username. If the identifier is not matching, say I have username as Owais Hussain, and in the provider I wrote Owais.Hussain, then the provider is going to get stay empty. This is going to cause an error in our system. So first things to consider, whenever you're creating a user, you're going to create a provider for that user with the same name, the same username. Okay, moving on, what happens next? We are fetching a concept. Which concept? We are fetching patient program ID concept. And now we are going to scan this encounter for an observation which matches this concept. For every observation in the encounter, if the concept is matching patient program ID concept, then we are going to go into this and we are going to fetch patient program. This is a patient workflow service, program workflow service, get patient program by UUID. We already have the UUID from the object we were intaking, and our patient program is going to get returned. So patient program is, again, we need its ID. What we are going to store in the observation is its numeric ID, patient program numeric ID. And this is, rules like these are what's making this module a bit fragile, because there's no way around it. We have to do some things in a particular manner. There is no separate table where we can create like a bridge. Okay, this is the patient, this is the program ID, these are the program IDs. Nothing as such. We have to make use of observations and store the references just like this. So there's no foreign key relationship. We have to rely on this piece of code that this is going to set the right value. Okay, now our input was simply was a simple TB03 form. We are now converting that form into a complete TB03 form, which is the heavyweight object over here. So set encounter type and get the smears, cultures, Heinz, everything about this TB03 form that happens over here. And as we look at the flow, we'll look into that as well. Now we have this so-called form service. MDR TB form service implementation is another service which is going to convert forms, or rather say process certain forms. So we have process TB03 form, TB03U form, form 89, adverse events form, regimen form. All of these forms are processed using this method, this service here. Now let's have a look at how TB03 form is processed. As you call TB03, I'm not passing on any location as of yet. Look what's happening. It's going to check for certain rules that this form should have an encounter. If not, throw an error. It should have a location property. If not, then check for the location inside the encounter. If this is empty, this location parameter is empty, then check for the location inside the encounter. If even the encounter doesn't contain that location, then throw an error. Location is compulsory. So meaning if this is empty, what we are going to do is we'll pick location from encounter and then set that. It's questionable. It can be argued, why do we have to go through this hassle? Why not just attach the location right over here? Why not just say simply delegate dot get encounter dot get location? Why not just do this? And in fact, not even this. Why not just pass on to TB03? So these are some things we need to refactor down the road. no time for this right now. Anyway, these are best practices. We can take care of them later. Handle cause of death. If there is a if the TB03 form contains cause of death, if it's not null, you need to set the respective field. Otherwise, the other cause of death will be put null. This is just another concept we are fetching, right? So the cause of death, the concept itself, should match this concept. You cannot just pass any other concept and let it accept it. So these are all your manual validation works. And now that we have some validation, we are saving the encounter. This will create a new encounter, right? The encounter is saved, but the workflow is still pending. You have to make certain updates to the workflow. So we are going to fetch outcome. If there is a treatment outcome, we are going to fetch registration group. We are going to fetch registration group by drug, and finally we are going to fetch the patient's TB program. Now this TB program could be MDR TB, it could be DOTS, whichever. Remember yesterday I explained how this is hardwired. These programs are not to be changed or altered in any way. This is why we have these portions of codes, which portions in our module code which are hard code, which are making use of those workflows as is. So any change in those workflows will mean breaking this method, this class, this functionality. So once you have patient program, you fetch the program object from it, and then you perform certain updates. So if there was an outcome in the TB patient program, you are setting that outcome, right? If there was a date of completion from the TB03 form, you are going to set the date of completion in the TB program. This is part of the patient's workflow, the business logic, and so on. So this is again a workflow for classification according to group, and then classification according to drug use. Patient program, we store a new patient program object, a new patient program if we are creating a new instance, and then the outcomes, if there are any, we check for the consistency in concepts, that the outcome ID should match the global property where we have defined the outcome, the exact property of the exact property concept ID for the death outcome. So the global property, the concept in the global property must match this concept over here. If the patient has died, then we declare the patient object as dead and set the cause of death. Finally, we are saving the patient object and returning the TB03 complete form. Now, this is the whole flow of one TB form, one TB03 form, that this is how it gets filled. And similarly, you can open any other form, let's say TB03U form, or let's say form 89. You will see the same pattern, the same set of rules, just plenty of code to view. Other than that, it's just the structure, the design for every form is just the same. So now we are talking about the form that gets filled, TB03 form that gets filled, right? Let's look into the service layer. See, this is only the OMod. This file here, the service resides in the API, right? It's in the API. So there's an MDR TB service, there's MDR TB form service, then lab test service. I'll come to this in a bit. where was I? Form resource controller. Now there is another one, another REST controller called TB03 data resource controller. What is this? This data is for report. This is for form, this is for report. That's a convention. Form, data, form, data. Form means the form and data means report. For report objects, we have yet many more properties to attach. But we don't need to make any changes to the data itself, so it's just search and fetch. Right? Now let's have a look over here. Do search. This is the part where one of your requirements come in place. You see, you are asking for month 1 and month 2, right? Or you are asking a quarter. In the UI, when you populate a new report, you are asking for year, you are asking for quarter, and then month range. Now in the UI, you may have just 1 month, you may have a start or end month, whatever. We can make changes over there, but the way it is being used right over here is like this. We have a TB03 export controller which takes these parameters in and returns a set of patient TB03 data objects. All of those data objects are converted into simple TB03 data objects, and this list is returned as an output. Again, you have just like you have simple TB03 form, you have TB03 data. Again, the same thing. It's just a matter of number of variables that exist in every class. That's why it looks like there's too much data to explore. It's not actually it's too much data, too many variables, but the code itself is not as complex as it seems. It just takes more time to work on it. Anyway, let's go over here. Get TB03 patient set. This is the part where you are fetching a report. These are where you will this is the part where you might be making more changes. So let's say there is a change and the change is, so we have month 1 and we have month 2. Let's see how this is actually working. We have a MDR TB service class and we are calling its method get TB03 forms field. Let's go to its implementation. Where is the, hang on, I need to search over here. Okay. So this is the actual service method that processes your request for TB03 report. It asks for locations if you're providing, if not, forget. It asks for year, quarter, initial and final month. Now from month 1 to month 2 you will create a data map. This data map is going to return a start date and end date. From these 3 parameters we identify the duration of in dates for the data to search. You can look into get period dates function. It's actually quite it gave us plenty of headaches to write this one and test it. It's quite bespoke and tailor-made. It did give us some headaches. There was actually one more condition, quarter, this one particular thing. Yeah, this over here, if you remember, Anwar, I think you explained that the month start and month end, the month ends at 25th and the new one starts on 26th, something like that, right?
Yeah.
That's
25th is the last day of month, 26th the first day of the next month.
yes. So as I was explaining earlier too, be very careful. Never ever let AI alter your code in the module. See, this is like a bug for them, for AI. Because AI knows a month does not end on 25th, it doesn't start from 26th. You'll have to explicitly tell the AI, no, this is not a bug, this is a feature, and there are like 100 of features like these. So how exactly are you going to create that prompt? Which is why I'm very reluctant. I'm warning you here. It has not worked for us really effectively. It's unlikely that it will work for you without going through a proper overhaul. Anyway, coming back, we now have a start date and end date. The rest is simple. We are only fetching all the encounters that lie within this date for this location for this patient. Sorry, not for this patient, for this date range. Now, this simple code over here tells you a big problem. Can you guess what that problem might be? The one we are facing right now. We've been facing for years. This one. Any clue? Okay, let me do this. As I explained,
Patience.
no, it's not actually locations. I explained that
Reports.
encounter and observations. These
Yeah.
are two very heavy and very frequently used tables in our system. When you search for data within these tables, the search query takes its due time. And when you give a broad range of dates, a whole range of dates, you're talking about months and months of data to retrieve. Months and months of data, not for any other small table, for the encounter table. And inside every encounter table, you have plenty of observations. All of those encounters will be read, all of those observations will be read, and they will be returned not directly, but first they will be transformed into TB03 forms. And this transformation takes place here. Then these forms further transform into TB03 simple forms, and it's those simple forms which are going to get returned. That's what takes plenty of time for our system to do, and thus you have so much delay when you are generating reports. Now imagine there's not one request but 5 concurrent requests for the same report. What's going to happen then? You may increase resources, you may do whatever you want, but there are only two possibilities. Either you stop generating reports on the fly and dedicate one person who is going to generate reports, only one person from the program, or you limit the data itself. So you can say you are not going to generate data, any report for more than 1 quarter. You'll have to say something like that, enforce rules like that. Or you will have to have a mechanism to schedule reports. So the user will be requesting a report and then collect the report as the report is ready. Something similar to what I tried to implement on a very small scale. Basically, by a small scale, what do I mean? What the Django application is doing currently is it is allowing only 4 reports at a time, and those 4 reports, whenever the report is ready to serve, the user gets that view report button enabled, and that's how they view the report, right? But this is only to fix a symptom, not the actual problem. So this is where all the main service level functionality are being performed. Rest, the OMod, entire OMod layer is for representation only. It only tells you how to collect data from the web app, how to send it to service layer, and then receive data, represent again into a flat format, and return. Now everything else, all the business logic, all the rules, these are being applied over here. Now we cannot go into the detail of every method that's being used inside here, but I'll just explain a few. So for example, there is this concept, MDR TB concept map. So what exactly is this? It contains a complete map of all concepts which are being cached, which are being changed. It keeps track of all the relevant concepts. By relevant concepts, what do I mean? See, OpenMRS may have thousands of concepts in its dictionary, right? But we are only concerned with the ones that are actively being used. And by actively being used, I mean it's not that you're going to pick all concepts and put them in cache somewhere. The MDR TB module maintains a cache of concepts. It does so, but how it does that? Initially, entire concept map is empty, right? But as soon as a concept is requested, this concept map gets updated. Let me give you an example somewhere. It's been updated. Yes, so we have this concept map lookup function, right? Now if you go into the lookup function itself, you'll see it's accepting a string. You're searching by string, and if that matching concept exists in this cache, I have this cache over here on top somewhere. Where is it? See, these are this whole list of concepts. These are all common concepts we're using. There are like 500-600 concepts, and all of them you will find over here in MDR TB concepts.java class. And then there is a map of cache. We are not using anything as like in-memory DB like Redis or Memcached. In the OpenMRS DB, we are just using plain flat memory because it's server. We have plenty of room for to keep data in RAM. So we have this map, and it maps strings to concepts from the dictionary. Why we are maintaining a cache is because concept is one thing that's very frequently being used very frequently. So fetching a concept every time from database searching, that's additional work. We just simply check for every string when it is first used, and then as the concepts are over here, as the concepts are being called, they are loaded into cache as well. So you can see if the concept is not mapped, is not found, if a matching concept is found in cache, it is returned. Otherwise we fetch the concept by name, and if we have a concept which matches exactly by name, then that concept is returned. Okay. But not as such, that concept is not returned as like one single as a whole list. There may be more than one concepts matching the same string. So first convert it into a list, and from that list we look into several other stuff. So there's a concept mapping code. If the code is matching, well, that's all the mappings are retrieved. So this is what this is the dictionary, concept dictionary for our module. So I explained about concept dictionaries, Nomad, Seal, etc. Our concept dictionary in this module is org.openmrs.module.mdr TB. That's the source. So if more than one concepts are matching, we look for the mappings and match the code, which is why it is compulsory to define a mapping. If you don't define a mapping for any concept, this part will not execute, because there will not be a mapping concept, a matching concept. This is why concept dictionary is one aspect which only, as I also recommended, only the admin, one super admin should be able to tinker with the concept dictionary, no one else. Now, so we have now retrieved mappings, and for each mapping what we are doing is we are matching locale. The locale should match, and for that locale we are as a concept is found, we are going to put it into the cache. But there's another function being called initialize everything about concept. It does exactly what the name says. Now you can see we are fetching HL7 code, we are fetching tags, we are collecting concept answers. That's concept initialization. Why do we need this? Because concepts are loaded lazily. What do I mean by loading lazily? So Hibernate has this feature called lazy loading and eager loading. Lazy loading says, let me see if I have any object to find somewhere here. Now let's say we have a lab test type tied with order entity of OpenMRS. So we have fetch type.eager and fetch type.lazy. Fetch type.eager means whenever this object is retrieved, say select status from lab test from the database, only the reference of order will be loaded. So order is a foreign key, has a one-to-one relationship with lab test. Only order rows, order tables primary key, a reference key will be loaded, not everything. That's when you have set the fetch type as lazy. So this makes the operation quite rapid, because you are not executing all those inner joins in your code. So you see, you have one relationship with order, another with lab type, another with lab test samples. There are multiple joins. So what Hibernate does is to make the operation fast, it does this lazy loading. Eager loading loads everything, the whole object, from retrieves the entire object and all its relevant foreign key objects, foreign key rows, and converts them into one big pre-filled Java object. But that although it gives you complete information, it has a cost. For an object like patient, the operation itself is quite costly. As I explained yesterday too, when you set your representation as full, the full object is retrieved from server when demonstrating the REST API. But then that takes a lot of time, like almost the double the amount of time, if you are fetching one say the whole concept dictionary with all information. So by default this is set as fetch type lazy in OpenMRS. Now since it is lazy, all other relevant information is not accessed when a concept is returned, and thus this information stays null. So initialize everything about concept basically calls all the concept tags once, it just calls getters, and with this the whole concept object, whatever you passed, is then loaded completely into the memory. So you see it is not returning anything, it's just calling a bunch of methods from the concept, and not everything. It's only calling concept name tags and concept answers. So when this method is done, the concept you are fetching over here now contains all the information in the concept object you want to return. Now from this point onwards, when the concept is initialized, it is returned, right? It is returned immediately if you are looking by UUID. So if your lookup string is a UUID, it matches whether it is a valid UUID or not. If it's a UUID, then the length of this string should be 36, and it should match the UUID regular expression. Here's the regular expression of UUID, meaning whenever in your code you're calling get concept, you can look up by name or by UUID as well. Now if you were searching by UUID, fine, it's returned. If not, then first you try matching the name precisely. So by precise I mean dot equals, right? Now all the list of all concepts are looked up by name, and from this whole list we only return the one. If there's only one match, we return it. Otherwise we match the fully specified English name. This again is an important aspect to let me load the concept mapping. As I was explaining the concept mapping, wow, where did this go? Okay, sorry, I think we deleted the ETL project. No worries, I'll load it later. So we had these concept mappings, and there's a column called fully specified name. That's the complete string which gets mapped, which gets compared with the incoming string. And if you have a results, if you have a matching result, that is returned. Otherwise this function returns none. So this is just one example of how the module handles one part of metadata. You will see same rules being applied on locations, on programs, on all other metadata elements, especially encounter and observations. Anyway, coming back, we looked into this process TB03 form, how this form is processed, and then we jumped to the MDR TB service. So this is a kind of a utility for concepts. I think I have this twice. Yes, see, this method exists in MDR TB concepts as well as MDR TB service implementation. Therefore, it has to be refactored. That's a problem. So over there it's protected, over here it's private. We could just turn it into a public function and call over here. Let me leave it to do here. One more thing, this /to do and /fix me, these are all where do I have them? These are all your tasks, pending tasks in the code. So wherever you get a chance to look into all the readmes, the MDR TB service implementation, there are plenty of functions to look into, and we are not going to go into each and every one, but let's just pick a few more to establish understanding. So let's say create specimen. You are going to input a patient and then call specimen implementation. Over here a new encounter will be defined, the patient will be set, and the encounter type will be what? Specimen collection encounter. And that's how you are creating a specimen object. Now you are fetching a specimen from within that encounter. Get specimen and all. Save specimen. You can see, even just to save a specimen you have plenty of prerequisites you have to go through, and yeah, so the whole thing is you have to think in terms of encounters and observations. Expect everything to be stored as encounters and observations, and the rest will all be fine. Now this cluster over here of functions, starting from location, you will see all location functions being present till line number 1289. As you know, we had our own implementation of locations, so don't assume that the code is going to do exactly what is being shown in OpenMRS. We have a few rules implemented which are hard coded. So we have a hierarchy defined for locations from within the code. Right now, let's go into those classes. So we have, for example, on top we have region. This part is also important. At first we have a base location. Now base location extends the OpenMRS's own location class and adds a location hierarchy property. Now location hierarchy is an enum which can be region, subregion, district, or facility. So these are the 4 hierarchies baked right into a code. It's not as if you are going to add another level on OpenMRS address hierarchy and expect that is going to reflect into MDR TB, because inside the MDR TB this hierarchy is hard coded. Okay. Now Having said that, every location is stored as one location object in OpenMRS, but over here in our module they are all treated as separate classes. So all the locations that are regions are returned as a region object. Similarly, there is a sub-region, there is a district class, there is a facility class. These are not adding any more variables, but what they save us from is writing if else everywhere. So you can call a location by the region, district and facility ID. This is to fetch any location given what information we're providing. So I'm going to use this very frequently, call region ID, district ID, facility ID, and then fetch the respective location. Similarly, you have a call by their fully specified objects, and then location list for Dushanbe. See, that's what I was talking about. We have some really hard-coded stuff going on, which you cannot rely on AI to fully grasp from every place. So we have a location list for Dushanbe, and it is going to return a list, but you won't see in this code that we have hard coded any identifier for Dushanbe. Now let me show you where this is coming from. So TB 03 export controller. Now this is the painful part. We are trying to get rid of these how do I say this, annoying hard-coded IDs, but still they are there in some places. So when you do a TB03 form, your module checks for oblast ID, the location ID, and if it is 186, means we are talking about Dushanbe. If it is Dushanbe, then fetch list for Dushanbe. Otherwise, the standard for every other location is the same. So yeah, watch for these traps whenever you're working on the module. I pretty much don't use ChatGPT at all whenever working on the MDR TB code. Where you will use it rigorously is the web application, and we'll come to that. So again, it's mostly about reading the existing code and then making any change. The reason it takes so much time it has always taken so much time for us to make changes in module is because of these rules we have, and it's not something we can do overnight. We can change overnight. Some of it, this part will stay as is, cannot be refactored unless there is an overhaul in the operational system in the field, which is not obviously possible. So anyway, that's where you are fetching a list of locations for Dushanbe specifically. Then list of countries not used really, we only have one. Get regions, a list of all regions, then one particular region, and these are all helper functions. Now there is another get registered facilities. What it does, this will be refactored in the current wave. What it does is it fetches this global property GP lab entry IDs. Now GP lab entry IDs is, let me show you, a hard coded let's settings. By the way, all of these MDR TB dot properties in global properties, these are all coming from our module. See, it's called MDR TB dot lab entry IDs lab. Let me check for this one in the code. Lab entry IDs. Is actually a property where we are saving these, and it would be good if this to-do is resolved. If not, that's good news. It means there's a bug somewhere. Anyways, let me see if I have this in the TB registries. That's where it's coming from. Yes, so as you can see, there is a global property called lab entry IDs, and it has pipe sign separated hard coded IDs of the locations, which are the ones these are GB lab IDs. So these are labs in the system. However, in our current upgrade, what we are going to move to is this. We are not going to hard code any IDs. We will just assign tags to locations. So for example, say pick this one. This location is a where is it? Is a GP lab, right? So you're going to specify tags. So for example, this is a laboratory, and this, once you have these tags, the code becomes dynamic. You don't have to, you can assign a new lab, create a new lab, or remove, and it won't matter because you are reading from the tags. So I left this to do, and it will be handled. We will be reading registration facilities via these tags. So similarly, we can fetch MDR TB facilities. We can fetch transfer locations where the extreme cases are referred to, and the labs where culture is being performed. So you can have these tags, and inside the code you can filter by tags. The level 1 is to have separate function for each of those tags. Level 2 is to make it even more dynamic and controlled from the front end, right? These are get facilities by parent. You are going to supply a parent ID and fetch facilities only from that parent. Get facilities by tags. This is I've already left it. It's not currently being used. This to do is pending. Have to do that again. get registration facilities by parent ID. Again, use location tags. These are how locations are being handled in our system at present, and this part will go through some level of refactoring, but again the hard-coded Dushanbe ID, we'll have to think about a proper solution for that. Okay, so actually yeah, here get enrollment locations, there is already one a tag I think we are using, admission location. So these are the locations where a patient can be enrolled for treatment, be it a DOTS program or MDR TB program. These are the locations where the culture test is being performed. So these are defined, but I had requested for these tags earlier, as I mentioned in day 1 too. You have to provide me against every each of these entries the right tags. What are the right location tags for each of the locations, and then this code is going to get refactored and it works out of the box. So anyway, this whole set is about locations. Then you have answer sets. So this is basically we have a question and you just return a collection of possible answers. So for MDR TB result, what are the possible answers? These are just the caller functions. They are doing nothing more, they're just wrapper functions and that's it. But some of them might change. So for example, get possible DST results. Now when it comes to DST results, we are hard coding susceptible to DSTB intermediate TB resistant, DST contaminated, and waiting for results. So these are concepts we are hard coding and returning. Why? Maybe because the concept is not yet turned into a proper concept set. So it's like a back and forth thing. You fix one thing in metadata and then fix the code and otherwise. So see, enable the line below and change the return type to concept answer. This is also a to do. Let's see what happened. It will be good to understand. Let's just explore why this piece of code is as such. So we have a concept called tuberculosis drug sensitivity result. Now the answers it has is okay, susceptible to tuberculosis resistant, concentration colonies, DST contaminated, and waiting for test results. We don't have colonies. We don't have colonies added as a concept, so that is not among one of the answers, which is why maybe it was filtered out over here. But such rules should be implemented not in the MDR TB code but rather the front end. So yeah, there's a to do for this one. Not really, this entire thing can go away, by the way. If you want to return MTB results, why even have something over here? Just do that in where it's being called. Yeah, let's put a to do. I think the reason is because this function calls OpenMRS's concept service, and in the entire code we are only calling MDR TB service implementation service. So there's just one service we are calling everything from, but that's not really a good design. Anyway, I'll refactor this into. Then we have forms. So smear form, culture form, all the forms. One method that is handling the fetch, and goes on and goes on and goes on. All of the forms are being handled over here. So get TBS03 forms filled. This is the function that gets called when you call a report, as I was explaining yesterday, why these take too much time. So anyway, the rest is all exploration, explore as you move on kind of stuff. We have these saved reports. Yes, that's also a feature. We can lock reports and save them. Reports can be voided, these can be unvoided. This is the only entity, I think, the only extra table defined for our module, for the reports, to save the reports. Let me double check this. I think that's it's called MDR TB item. No, it's report data. Yeah, the table named report data is the one that contains reports in hard coded stored format. These are locked. So that's our custom table, and it is being used very loosely. So the content itself, the entire table, is loaded as a long plain text string. Now this is not the same string, it's compressed and then decompressed on the fly, but the point is this table contains all your locked reports. So save, get saved report, and then get report data. You convert this into report data object and then read it accordingly. See this, get locations with any program enrollment. To do move to locations section. Get all Ryans for Tajikistan. Anwar, can you remind me what RAN is?
What? Sorry?
RAYONS, RANs. It was related to locations, something like that.
The districts.
Oh, these are literally districts. Okay.
Yeah, rayons you mean, yeah?
Yeah.
Yeah, it's districts.
So why it's okay. Yeah, it should be just get all districts then. But anyway. Okay, get drug orders and all. Cutting short, you have to thoroughly study the MDR TB service implementation class, and for the DAO you have MDR TB DAO. These are two sources of truth to understand the overall structure of the system, the module. I'm not going to spend too much time again on every class. It's explore as you need basis kind of thing, and not every class needs to be understood too. So there are plenty of changes for which you'll just touch 1 or 2 or 3 more classes and you'll be done. So the module itself works. It is quite bug free based on the requirements. It obviously needs refactoring. That's one major thing that's pending in this module, and we've also thought of refactoring as okay, we were gonna do that later. So that later actually never came. There are this code is still much more refactored than the first version you'll see, but still it's some part of it is still a mess. Now let me tell you one more thing that's important. In this revision, I have merged all the lab functionality inside the MDR TB module. So the common lab modules dependency no longer exists. All of that functionality has now been moved inside our module over here. Meaning the common lab test module I showed yesterday, that whole module is now part of MDR TB module, but we have renamed a few of the stuff was renamed. So you can see lab service. This is for testing. Let me show you the resources. Yeah. So this same liquid base I showed you yesterday, you're gonna find here as well, except that the names of entities have been changed from common lab test to lab test. So right now, if you look into the existing deployment, you'll see common lab test attribute, but the upcoming version after migration, it is going to be lab test, and this is now part of the MDR TB module we have. Alright, so nothing apart from that. It's the same, it's a clone of the same lab test service I showed yesterday in the lab test module. So now you don't have to worry about 2 different modules whenever making certain change as well. If there's any change you need in the lab services, that's where you do that. And this is lab DAO. All the lab related objects are can be found in lab test attribute, lab sample, lab test group, all of that. There's one more aspect I wanted to show you. AOP, aspect oriented programming. Because whenever you're dealing with OpenMRS, aspect oriented programming is a headache to work on when debugging. So this is an entire mode of programming. It follows a certain design pattern. We have this concept of inversion of control in software engineering. So aspect oriented programming implements inversion of control. What it says is, have a look over here. It says whenever in the code you are executing a function that any method that that is equals to void encounter, you do this. Wherever you have unvoid encounter, you do this. So when you're voiding an encounter, you're also going to over here, void its respective lab test. When unvoiding an encounter, if it's tied to an order, you will also unvoid its respective orders. And since this is not defined in the service class, it will also, like, it comes as a massive surprise when debugging where this part is, when this stuff, where this stuff is happening, because you're never calling, you're not writing this anywhere in your service. So when debugging, you go line by line and you don't find any line which is avoiding the order itself. That line is not found because it is moved into aspect-oriented programming. The control has been flipped from one class to another class. So through our aspect-oriented programming, you can control your entire code base. You can capture logs, capture exceptions, capture warnings, and you can log anything without mentioning anything as like loggable. Let me see if there is one I can explain with an example. Yeah, I'll open another project, by the way, just to explain this one. It's quite yeah. So let's say you want logging enabled in throughout your application. Instead of writing calling log function in every single function, you can have a logging aspect and make it scan the parts of code where logging is required. Now how do I do that? I'm creating an annotation in any function. So for example, let's say provider service, CPU, let me pick some looks like strange. Maybe it's not being used right now. If it's not, then it's quite weird. No, it is being used in another module. So you see, for example, this is method pull Olama model. All I did was write @loggable, and this method starts to get logged. So whenever this is called, a log will be recorded. Basically, I just wanted to show you as an example to not worry in case you are unable to trace where a certain action is happening in OpenMRS. See, in OpenMRS, you cannot change, for example, a date created. If you try to do that, the OpenMRS's own guards control written in AOP are going to stop you, keep you from doing so, because by rule you cannot do that. So anyway, coming back, this was an important thing to discuss here. Save lab test samples, save lab test types, these are all the same functions we have already covered in the common lab module. There's a couple more classes I now want to show you. Let's close everything for now, and in the API, let's talk about all these. First and foremost, the activator. As you guys know, a module is controlled by its lifecycle is controlled by OpenMRS and OpenMRS looks for this activator class. In activator class, what we are doing is we are setting up certain concepts, certain global properties, whatever we want to launch at the startup happens over here, right? So this is activator. Then there is an MDR TB config. This whole part is you can say pending, because this entire this entire module works on one privilege, which is called edit dots or MDR data. Meaning, if a user has a privilege to has this privilege, they can alter anything in the module, and this has been the way since day one. If you guys have a whole structure of how the privileges should work, if you have a limit, you want to put a little limitation on, okay, these are dots users, they shouldn't be able to touch MDR data, these are MDR users, they shouldn't be able to touch dots data, the lab guys shouldn't be able to call any lab any forms other than the lab forms. If you have those rules in place, you would be able to create further roles and define their privileges over here. So this is done comprehensively for lab module, but not the MDR module. Actually, let me show you the privileges for lab. They are defined here. So all lab privileges you're gonna find here, but there are no custom privileges for the MDR module. But this is again something, if you want to do, I would highly recommend you do so. But if it's not essential, not required, maybe you can skip this too. Not to worry too much about. Next, we have MDR TB constants. Some constants which are being used throughout the system, those are defined over here. Okay. So there are constant strings. Then we have encounters. All the encounter types are already prefetched as the module starts, and they are later used wherever they're required. Some of this code is obsolete, needs to go away. So for example, dots ID type, patient identifier dots, this is fetched but not used. It's used on the fly, so we can remove these two variables. There are those things. Then there's this DST MGIT string, DST LJ string. Basically this is all bespoke code. Then we've already talked about the concepts class, contains all the concepts being used in the system. We have MDR TB contact person. So this was again created for MDR TB contacts, and we have a relationship. So if two people are, if one person is a contact of another one, this is the entity class to represent that. And then there's also a controller for this get patient and set the contact, etc. Okay, then there is another entity called MDR TB treatment supporter. So just like we have a contact, we have a treatment supporter. This class represents the treatment supporter. And finally, we have a util class. Util class is not exactly a service class. This provides several utility functions. This whole class needs to go away. Because it confuses a lot when coding. If I want to find a method, should I find in services or in the util? So this is MDR TB util. There's also a TB util. These two are basically clones. These are like identical if you look into them, except that one is for dots program, one is for MDR TB program. So again, I'm going to actually what I'll do is I want to remove both of them. No, I just thought of something. This is too big a change. Let's not break this running system. So anyway, these two classes, MDR TB util and TB util, these are providing utility functions for dots program and MDR TB program. Alright, this is your API. This entity report data, as I explained, what this does is just it stores data in the table and retrieves it. When you call get table data, the data is decompressed and returned as a large string, and when you set table data, the incoming table data is compressed and set into the field. That's basically it to this function. Okay. Next we have these. Actually, this one is not applicable. These have to go. The translations should exist over here in OMOD. So we have Russian, we have Tajik, and where do I have it? The API itself should not be handling any translations, because translations related to the web and the external end of the system, not internal. So there shouldn't be any translations happening. It's happening because of the reports. We are calling reports as generating reports over here, and the reports, they contain translated data. That's why they're here. But ideally there shouldn't be any translations happening in the API level. They should be in the OMOD level only. Anyway, we talked about API broadly. Now let's go to the OMOD. In the OMOD, you will be mostly dealing with the REST resources only. But what else is there? So let me show you what else exists. This is DTO. These are all lightweight objects for transportation. These are legacy controllers for the old forms. This whole code needs to go away. See, program controller underscore original. That's, sadly, you will see stuff like this. But anyway, this entire controller layer, this whole code is to support these JSP pages, and these pages are coming from the old UI. So all of this stuff needs to be cleaned, needs to go away, because we now have a separate web application. The reason why this was kept as is to understand how the work used to happen pre Django web app. But once we have all these forms inside the Django web app, this is no longer required. I'm going to remove all of this JSP code. I'm going to remove its related controllers, and basically we will leave no trace of the old way of handling the module. So that's the plan of, that's among the refactoring things that we never get time for. That this time I'm really going to do this. That's a promise to myself. Alright, so this is again the same stuff, admin list, then get item. So right now in the admin list we have just home page, which basically takes you to the MDR TB web applications. Right now it's not working because it's leading us to the local host page. Well, so this has been, by the way, fixed in the current version that's deployed in the new test instance.